From nuclear-powered satellites to a thruster that never runs out of fuel, this is Astronomy Daily.
I'm Avery.
And I'm Anna. It's Wednesday, July 8th, 2026, and this is Season 5, Episode 135.
Big show today, Anna. We've got a genuine technology first, a Kiwi engineering trick that sounds almost too clever to be true, a plot twist 5 years in the making, and, for once, a story that isn't about our Southern Hemisphere listeners.
That's right. Today, we're tipping our hat to the northern half of our audience, who make up the bulk of our listeners, but don't always get a sky story written just for them.
Plus, a serious look at planetary defense, and we close things out with an astronaut who's already planning his next chapter, just weeks after circling the moon.
Let's get into it. And let's start with a genuine first. On July 7th, SpaceX's Transporter 17 rideshare mission lifted off from Vandenberg Space Force Base carrying 81 payloads. And tucked among them was something that's never flown before on a commercial mission.
This is the Bohr CubeSat, built by a Florida company called City Labs, and what makes it special is what's powering one of its payloads, a tiny nuclear battery.
Now, before anyone pictures a miniature reactor, this is something much gentler. It's called a beta voltaic device. City Labs calls the technology nanotritium. It takes the beta particles thrown off as tritium decays and converts them directly into electricity through a semiconductor.
The power output is tiny. We're talking micro to milliwatts, not enough to run your kettle. But here's the trick. It's continuous. Day or night, in sunlight or in shadow, it just keeps producing power.
And tritium has a half-life of 12.3 years. So this thing stays effective for 20 years before it quietly decays into harmless helium-3.
The FAA had to sign off on this one too. They concluded that public radiation exposure from the mission would stay under 1 millirem, using conservative assumptions. So this has been vetted from a safety standpoint, not just an engineering one.
City Labs CEO Peter Kamo'oalewa called it a historic step for commercial nuclear power in space, and said it enables, quote, persistent, always-on payload operations that are not constrained by sunlight or battery life.
Worth being clear, this isn't like the plutonium RTGs powering Voyager or New Horizons, or the Mars rovers, which generate power from heat. This is much smaller, much lower power, and it's still relying on solar panels for its main systems. This is a proof of concept.
But it's a proof of concept with a very specific use case in mind. Permanently shadowed craters on the moon, for instance, where the sun genuinely never reaches. NASA's floated tritium beta voltaics as a way to run small autonomous sensors in exactly those conditions.
Solar panels have run space missions for 7 decades. This is the first real commercial attempt at an answer to the question, what happens when the sun doesn't reach you at all?
It's a small battery, but if it scales, it opens some very dark corners of the solar system.
Sticking with clever engineering, this next one comes from a lot closer to home for you, Anna.
It does. This is a New Zealand story. A company called Zenno Astronautics, a spin-off from the University of Auckland, has just completed the first orbital test of something called the Supertorquer.
And the pitch here is genuinely wild. It's a thruster that never runs out of fuel because it doesn't use any fuel at all.
Here's how it works. The Supertorquer uses superconducting magnets powered by the satellite's solar panels, and those magnets push against Earth's own magnetic field. That interaction generates torque, enough to turn and orient the satellite with zero propellant consumed.
Superconducting magnets have been on people's wish list for this kind of job for years, but the hardware was always too big and too complicated to fit on a small satellite. Miniaturization has finally caught up with the idea.
To be precise about what this replaces, it's primarily for attitude control, so turning and orientation, rather than big orbit-changing maneuvers. It's a much cleaner alternative to the cold gas thrusters satellites currently use just to point themselves the right way.
But if you never need propellant for that job, a satellite's operational lifetime stops being limited by how much gas it launched with.
Zenno's own messaging captures the ambition nicely. They say they're trying to, quote, remove all reliance on Earth's resources so that we can build a sustainable industry in space. No tanks, no valves, nothing to run dry. Just magnets, sunlight, and the planet's own magnetic field doing the work. A very Kiwi way to solve a very old space problem. Now to an ongoing story that just took a genuine twist. Longtime listeners will remember we've been tracking China's Tianwen-2 mission on its approach to the near-Earth asteroid Kamo'oalewa.
Well, on July 6, after a 400-day, roughly 1 billion kilometer journey, Tianwen-2 arrived, settling in at a station-keeping distance of about 20 kilometers from the surface. China's space agency released the first close-up image the same day.
For context on what Kamo'oalewa actually is, it's one of only 7 known quasi-satellites of Earth. It orbits the sun, but it stays locked in a stable dance alongside our planet, and has done so for roughly 100 years, with about 300 more to go.
The image shows a small asymmetrical rock, somewhere in the range of 20 to 30 meters across. Tiny as these things go.
Now, here's where it gets interesting. Since 2021, the leading theory has been that Kamo'oalewa is a genuine chip off our own moon, blasted off the lunar far side by the impact that created the Giordano Bruno crater, somewhere between 1 and 10 million years ago. That was based on its reflectance spectrum looking a lot like space-weathered lunar soil.
But just 5 days before Tianwen-2 arrived, a JWST preprint modeled Kamo'oalewa's albedo, how reflective it is, at 0.59. The moon's albedo is only about 0.12. That's a huge mismatch, and it's simply not compatible with a lunar origin.
Astronomer Mikkel Grandvik of the University of Helsinki says the new Tianwen-2 image basically confirms the high albedo result from the JWST data, pointing instead toward Kamo'oalewa being a rare type of silicate asteroid entirely unrelated to our moon.
For 5 years, the story was it's a piece of the moon. That story might not survive contact with the evidence.
Which is exactly why Tianwen-2 is there. Over the next year, it'll study Kamo'oalewa with 11 science instruments before attempting to collect somewhere between 20 and 100 milligrams of surface material, using whichever of 3 sampling techniques suits the asteroid's surface best.
Sample return is planned via an Earth flyby around April 2027, and only then will we really know for certain what this little rock is made of.
The only way to settle it for good is to bring a piece of it home. Now, staying with asteroids, but shifting from origins to defense, because a new study out this week tackles a question that sounds like it's straight out of a disaster movie.
How exactly do you nuke an asteroid, if it ever comes to that? A peer-reviewed paper published July 7th in the journal Space, Science and Technology models 2 different approaches to nuclear asteroid deflection.
Model 1 is what you'd probably picture, an impact detonation. You hit the surface, create a shallow crater, and detonate a nuclear device there.
Mode 2 is more elaborate, a pre-excavation detonation. A penetrator device digs a deeper crater first, and then the warhead goes off inside that crater, achieving what the researchers call deep detonation within the asteroid's interior.
The researchers modeled the energy of the launch vehicle, the impactor's velocity, and the resulting change in the asteroid's own velocity for both approaches, and then tested them against a virtual database of threat asteroids, assuming warning times anywhere from 1 year to 20 years.
The headline finding, if you've got enough lead time, the deeper pre-excavation approach is markedly more efficient at actually deflecting the asteroid. But if warning time is short, a simple surface impact detonation may be the only option you've got time to pull off.
Worth saying clearly, there's no known asteroid threatening Earth right now. Apophis, once flagged as a risk for its 2029 and 2068 close approaches, has been ruled out as a hazard for the foreseeable future.
But it's not purely theoretical either. Back in 2024, a lab experiment published in Nature Physics showed that X-rays from a nuclear blast could genuinely vaporize and push an asteroid's surface. And the researchers behind that suggested the technique could scale up to asteroids as large as around 4 kilometers across.
And it's worth remembering the Chelyabinsk meteor back in 2013. A comparatively small object, and it still caused real property damage and over 1,000 injuries. Even modest-sized asteroids are worth taking seriously.
Hollywood's favorite plan, nuke it, might genuinely be a good idea. It's just that exactly how you nuke it turns out to matter enormously.
Not quite the Bruce Willis version, but planetary defense science is getting a lot more precise, And that's exactly what you'd want if we ever had to use it for real. All right, time for something a little different. Avery, I believe this one's got your name on it.
It does. Southern Hemisphere listeners, feel free to sit this one out for once because this Aurora alert is entirely for our friends up north.
Base weather forecasters are watching two things line up for July 9th. First, a fast coronal mass ejection that launched from the sun on July 5th, with a modeled arrival time around 6 UTC on the night.
A second, a coronal hole, a patch of open magnetic field letting fast solar wind escape, is rotating into an Earth-facing position, and its high-speed stream is expected to arrive around the same time.
Put those two together, and forecasters say we could see G1 class geomagnetic storm conditions. Minor on the storm scale, but enough to bring the Aurora down to some surprisingly accessible latitudes.
The zones to watch: Seattle, Edinburgh, and the northern tier of the United States and Canada.
For context, this comes right after last week's monster sunspot regions rotated away to the sun's far side. And they didn't go quietly, putting on a real show of flares and prominences on their way out.
Solar activities dropped back to low levels since then, mostly common C-class flares, with active region AR4482 now the main feature we're watching on the Earth-facing side.
So if you're anywhere near Seattle, Edinburgh, or the northern reaches of the US and Canada, July 9th might be worth stepping outside at night and looking up.
We don't say that to you nearly often enough. Consider this one a thank you note.
And we'll close today with a story about what comes after the mission of a lifetime.
Jeremy Hansen, the Canadian Space Agency astronaut who became the first Canadian ever to fly around the moon back in April aboard Artemis 2, announced on July 6th that he's stepping back from full-time astronaut duty.
Hansen flew as mission specialist alongside NASA astronauts Reed Wiseman, Victor Glover, and Christina Koch on the first crewed moon mission in over 50 years.
The transition takes effect this September, after 32 years of military service and 17 years as a CSA astronaut. He'll continue on as a reservist with the Royal Canadian Air Force, and says he remains fully committed to Canada's space program, just in a different capacity.
It's a nice detail that his Artemis 2 mission patch incorporated elements of Anishinaabe culture, reflecting a vision quest he undertook at Turtle Lodge in Sag King First Nation during his training.
In the months since the mission, he's taken on something of a public diplomacy role too. Appearances at the White House, before congressional committees, and at both Canada Day and Independence Day celebrations, championing the 6 decades-long partnership between the U.S. and Canada in space.
His departure leaves the CSA with 3 active astronauts in its core. But as Hansen tells it, this really isn't a departure at all.
Weeks after becoming the first Canadian to circle the moon, and he's already planning his next chapter.
A good reminder that flying to the moon isn't the end of an astronaut's story. Often, it's just the most famous chapter in it.
That's it for today's show. A nuclear battery, a fuel-free thruster, a plot twist 5 million kilometers from home, some serious planetary defense, an Aurora shout-out for the North, and an astronaut already planning what's next.
Thanks for spending part of your day with us. Find full show notes, sources, and links at astronomydaily.io, and follow us at Astro Daily Pod for updates between episodes.
We'll be back tomorrow with more of the universe's news.
Until then, clear skies.